Hello friends, Assalamu alaikum. You're watching Shams Mathematics Academy and I am Shamsuddin. Today our topic is the straight line. The straight line. The straight line. Okay, so this is the chapter number 2. Chapter number 2. Class second year. Okay, some textbook board. So we discussing here about the all the definitions and formulas of the straight line. Okay, from that it will be the new chapter, third chapter, the general equation of straight line. Today, second chapter, the straight line. So here first of all is the Cartesian coordinate, Cartesian coordinates. Cartesian coordinates. Cartesian coordinates. So the Cartesian coordinates is here. This is here two lines. So this is the plane. This is, we can say this is the plane. Here this is the x-axis and this is the y-axis. Okay. So this plane here, this is the first quadrant. You do first quadrant and second quadrant, and this is the third quadrant, and this is the fourth quadrant. Okay, so here in y-axis we can say this is the abscissal, abscissal, and this is the ordinate. Both x comma y is called coordinate. Okay, coordinate. So from in first quadrant x and y both are positive, and second quadrant y positive but x is negative, and third quadrant x and y both are negative, and here we can say x is a positive and y is a negative. Okay, so this can, we can say this is the plane and this is the two dimension here, y axis and x axis. So this is the two dimensional plane, this is the surface we can say. So here this is the y axis and this is the x axis. So you are familiar about that in previous classes. So now we can discuss the first topic from here. So this topic is the distance formula between 2 points. Distance formula, distance between 2 points. If we have given 2 points here, this is the P1, we can say x1 and y1, and this is the P2, we can say x2 and y2. Okay, so draw the Cartesian coordinate is here, system here. So this will be here. So here we can say this is the x1, and here we can say this is the y1, and here we can say this is the y2, and this can be say this is the x2. Okay, so from that we can draw this line. This is the perpendicular line. So here this is the right triangle. So this is the right triangle. Here this is the point Q, we can say. So this will be x2 and y1. Okay, so the distance of this line here, we can say that the difference between 2 points, so this will be x2 minus x1, and from here what will be the distance here? X2 minus x2 will be cancelled and y2 minus y1. Okay, so this is the right triangle. So right triangle always follow the Pythagoras theorem. So by the Pythagoras theorems, by the Pythagoras theorem, Pythagoras theorem. So the Pythagoras theorem in history of mathematics, we can say this Pythagoras, an ancient period. This is the man from the ancient mathematics. So this can be say he was the father of mathematics. Ancient Greek mathematician Pythagoras is the father of mathematician. Okay, so Pythagoras theorem is here. We can say P1 P2 whole square is equal to P1Q whole square plus Q P2 whole square. Okay, so we can say here P1 and P2. So this is the distance here. So we can say this distance is the D. So D square is equal to here x2 minus x1 whole square plus y2 minus y1 whole square. So taking square root on both sides, D is equal to under radical x2 minus x1 whole square plus y2 minus y1 whole square. So this is called the distance formula. Taking the square root on both sides, we can say that here plus or minus. So distance is always positive. So we can say that this is the positive value and we neglect the negative value. Okay. So distance from origin, distance from origin, it will be equal to under radical x square plus y square. Okay. Now the other formula is here. So this formula is called the division formula. Division formula. Okay, division formula. So division formula, internal division and external division. First is the ID, it means internal division. Internal division. If we have a line, here this is the P1, so x1 and y1, and here P2, this is the x2 and y2. Here is the point P, this is the x and y, and this is the M2 and this is the M1. Okay, so draw the Cartesian coordinate plane. If we draw here Cartesian coordinate plane, so here we can complete here. This is the right angle triangle here. So this is the x2, this is the x, and here this is the x1, and also here this is the y1, and here this is the y, and here this is the y2. Okay, so this point we can say this is the point R. It's a point R. So here point R will be x and y1, and here this point will be S. So here this will be, so we can say that x and y, x2, x2, and this is the y. Okay, so these are the two triangles. Here this is the triangle P1R P, and the triangle P S and P2. Okay, so These are a similar triangle. So similar triangle because similar triangle are the corresponding angles are congruent. This is the angle 1 and this is the angle 1. These are the congruent. This side and this side is the congruent, and also this side and this side are not side, but these angles are congruent. This angle and this angle are congruent. This angle and this angle are congruent. Now side are, may not be congruent. Side are not congruent, but angles must be congruent. Corresponding angles must be congruent, and we can say that the ratio of sides are equal. Ratio of corresponding sides are equal. So we can say that ratio of m1 divided by m2 for x. For x we can find this will be, so this is a m1 and this is a m2. So here we can say that m1 divided by m2. So here p1 is equal to p1 r divided by here p in s. So the line here, what will be the distance is here? Here this will be y1 minus y1 will be cancelled. So this will be x minus x1, and here this will be x2 minus x. Okay. So this will be, here we can say that x minus x1 divided by x2 minus x. Calculate this. How to, when we calculate this one, so this will be, we can say that here m1 into x2 minus x by cross multiplication, by cross BCM. So we can say by cross multiplication. Okay, here this will be equal to m2 is equal to x minus x1. So this will be m1 x2 minus m1 x is equal to m2 x minus m2 x1. Okay, so this will be minus, we can change these terms, m1 x plus m2 x is equal to m1 x2 plus m2 x1. So x is common from here, so this will be m1 plus m2 into x is equal to m1 x2 plus m2 x1. So we can say that x is equal to m1 x plus m2 x upon m1 x2 plus m2 x1 upon m1 plus m2. Okay, so this is the value for x. Now for y, we can say for y we can say m1 divided by m2 is equal to, here this will be rp divided by sp2. Okay, so here x1 we can say that x minus x1, and here will be x2 will, oh sorry, not x, x will be cancelled to x. So this will be here y minus y1, and here this will be x2 will be cancelled in x. So we can say that here y2 minus y. Okay, so this will be, here we can say that y minus y1, and here y2 minus y. For calculating, simplifying, this will be equal to y is equal to m1 y2 plus m2 y1 upon m1 plus m2. Okay, so the value of this point is equal to here x comma y is equal to m1 x2 plus m2 x1 upon m1 plus m2 comma m1 y1 plus m2 y1 m1 y2 plus m2 y1 upon m1 plus m2. Okay, so this is the formula division, internal division formula. So what will be the midpoint formula when the ratios of the are equal, when m is equal to m1, m is equal to m1 is equal to m. So this will be equal to here x comma y is equal to here m x1 plus m x2 upon m plus m, and m y1 plus m y2 here m plus m. So simplify x comma y is equal to here m is the common, then x1 plus x2 here 2m, and here m also common, y plus y2 upon 2m. So m will be cancelled in m. So this will be p x comma y is equal to x1 plus x2 upon 2, and here y plus y1 upon 2. So this is called the midpoint formula. This is called midpoint formula. Okay, this is the midpoint formula. Now for the other formula, this will be internal division. Internal division. Internal division. This is the internal division. Now for the external division. External division. When point divide from the outside the line, so this will be here. This is the line. Here P1 is here. X1 y1, here point is the P2 x2 and y2, and here is the point px and y. So we can say that m and y, m1 and m2 divided, is the externally divided. So this will be here. We can draw this Cartesian coordinate system here. This will be here. We can say and this will be here. So here this is the x1, and here this is the x2, and here this is the x. Okay, here this will be y1, and here this will be y2, and here this will be y, only y. So this is the m1 and this is the m2, m1 and m2. So the point of this triangle, this will be p, or we can say this is q. So the point is here x, here this is x, and this is y 1, and the point of this here we can say this will be s. So this the point is here we can say x and y2. Okay, so here are two triangles, two right triangles. This triangle here, triangle we can say that p1 q and p, and other triangle is here p2 s and p. So these are the right triangles and these are the congruent triangles. Okay, so the measurement of this side, what will be the length of the side? The side will be, we can say that x1 x minus x1, y1 minus y1 will be cancelled, and here the side will be, for the side here, x2 minus x1, it means x minus x2. And here for this side, this complete side is here. For this complete side, we can say that y minus y1, and for this side here, this can be, we can say that y minus y2. Okay, x for for x for x we can say m1 upon m2 is equal to p1 q divided by here p2s p2s. So m1 upon m2 is equal to x minus x1 upon y, oh sorry, x minus x2. BCM, BCM, and we can calculate. So result will be here. X will be equal to m1 x2 minus m2 x1 upon m1 plus x minus m2. And for var, same thing for var. We can say m1 upon m2. So this will be equal to, here this will be this the triangle. So the side is here y minus y1 upon y minus y2. So this will be also y is equal to m1 y2 minus m2 y1 upon m1 minus m2. So point is here p of x comma y is equal to m1 x2 minus m2 x1 upon m1 minus m2. Here m1 y2 minus m2 y1 upon m1 minus m2. So this is the formula. This is the internal division, external division. So in external and internal division, there is difference for the sign. So here this is different is where here is the minus, and internal division here is the plus. Okay, so it's not a main difference. Okay, now this is the quick review for this chapter. We cannot solve any example and any exercise problem. We only solve for the discussing only formulas for the chapter. Okay, so the other definition, okay, we will follow. Locus of a point. Locus of a point. Locus of a point. So if we can say y is equal to f of x, so this is the function set of all points, set of all points which satisfy this form, or x comma y is called locus of a point. So the many examples of the locus of point. So you can say the definition of circle set of all points in a plane which are equidistant from a fixed point is called the circle. So this is also the locus of a point. And set of all points in the plane whose distance from fixed point to the fixed line is equal. So this is called the parabola, and this is also the locus of a point. Okay. So other examples you can find. So this is the only definition. Now inclination of a point. Inclination. A positive angle. A positive angle on the x-axis in the upward direction with direction of line which is not parallel to x-axis. So we can say this is the x-axis here. This is the plane. So here this is the positive angle alpha. So this angle is called the inclination. This angle is called inclination. Okay, this angle is called the inclination. So and slope, the trigonometric tangent ratio of inclination is called slope. So when we say that the trigonometric tangent, so we can say that m is equal to tan alpha. So here m represents the slope of the line. It means the trigonometric tangent ratio. So there are the 5 other also trigonometric ratios. So these the ratios not define the slope, as only one ratio, tangent ratio can define this is the slope. Now for the slope, how find the slope? How to find the slope? Find slope when 2 points are given. When 2 points are given. Okay. So this will be how to find slope when 2 points are given. So we have a 2 point here. This will P1. So x1, y1, and this is the P2 here, x2 and y2 in Cartesian coordinate system. So we can complete here. This will be this alpha. So this is the complete. This is the right triangle. So here this is the Q we can say. So here x2 y1 and the here the distance will be difference in these coordinates here, x2 minus x1, and here also x2 will be cancelled, so y2 minus y1. So we can say that tangent ratio is equal to perpendicular upon base. So tangent tan alpha is equal to y2 minus y1 upon x2 minus x1. So we can say m is equal to y2 minus y1 and x2 minus x1. Okay. So this is the slope when 2 points are given. When 2 points are given, then we can say this is the slope. Okay, so and other definitions we will discuss it here. Now these definitions are what are the here slope in this line, slope on y-axis is 0. but slope is here, slope on y-axis is infinite. So here when we going there is the infinite slope. Okay, so okay, when the negative slope represent the obtuse angle and positive slope represent the acute angle. So when this will be here, you can say if the slope is here, so this is the alpha. Alpha is a positive angle. Okay, so here tangent ratio is a positive. Tangent ratio is a positive. So because this is the first quadrant, and here when the slope angle is here, this is the beta. So here in second quadrant, tangent ratio is negative. Tangent ratio is negative. So we can say that positive slope represent acute angle and negative slope represent obtuse angle. Okay, so this can be, we can define here. So when the angle in this first quadrant, so here tangent ratio is positive, in second quadrant tangent ratio is negative. Okay, so this will be obtuse and acute angles. Now when line are parallel, then slope is equal. When line is parallel, then slope is equal. When lines are parallel, when lines are parallel, then slopes of these lines are equal. So we can say M1 is equal to M2. If we have two lines here, this line and this line, so these are the parallel lines. So when we can say in Cartesian coordinate system, so here also these lines, so here alpha and here also alpha, this line, these lines is L1 and this L2. So these lines are parallel. When lines are parallel, then angle between them is the same. Angle between them can be same. So when lines are perpendicular, so we can say here you can see line 1 and line 2. So this is the L1 and this is the L2. This is the Cartesian coordinate system. So here when this lines, the line 1 here made here angle, this is angle alpha 1 and this angle also alpha 2. Okay, so according to the interior angle theorem, according to the interior angle theorem, so we can say the measurement of this angle is equal to sum of inside the angle of triangle equal to the sum of this angle and this angle. So we can say that here angle 2 is equal to uh, angle 1 plus 90 degree. Okay, so we can say take tangent ratio on both sides. So this will be tan alpha 2 and here this is tan alpha 1 plus 90 degree. So this will be here tan alpha 2 is equal to minus cot alpha 1. So you know here this will be tan theta plus 90 degree is equal to minus cot theta. Okay, so we can say this will be m2 and this will be 10 alpha 2 is equal to 1 upon 10 alpha 1. So we can say this is the m1 and this is the minus m1 upon m2. And we can say this can be here m1 into m2 is equal to minus 1. So we can say when lines are perpendicular, then product of their slopes is minus 1. Okay, clear? Now another topic is here. We can define an other topic here. So this will be angle between two lines in slope form. Angle between two lines in slope form. Angle between two lines in slope form. So when we can say here is the L1, it means line 1, and here this will be L2. We can say that from L1 made the angle theta. So how to define this? So this is the x-axis and this is the y-axis. So here we can say here this angle and these are the vertical opposite angles. So here this is also the angle theta. Here we can say this is the angle alpha 2 and here is the angle alpha 1. Okay, and here this the angle is the theta. Angle is the theta, or we can draw the parallel line to the x-axis here. So this angle and here this angle. So this is the alpha 1 and here this angle and this angle are alpha 2. So how to find the theta? We have formula, derive the formula for theta. So this will be angle 1 and this is the angle 2. Okay, here complete angle. So here this complete angle is this angle, complete angle from here. So this is the alpha angle and this will be the alpha 2. So we can say that theta is equal to alpha 1 is equal to alpha 2 plus theta, or we can say this will be here theta is equal to alpha 1 minus alpha 2. So tan theta is equal to tan alpha 1 minus alpha 2. So this will be tan theta is equal to here tan alpha 1 minus tan alpha 2 upon here 1 plus tan alpha 1 and tan alpha 2. So we can say tan alpha is equal to m1. So tan theta is equal to here m1 minus m2 upon 1 plus m1 and m2. So this is the theta between two angle between two lines. So now when L1 is parallel to L2, so we can say that theta is equal to 0 or pi. So here tan 0 is equal to m1 minus m2 and 1 plus m1 into m2. So this is a 0 here, m1 minus m2. So when we multiply here, cross multiply, this will be 0. So we can say that m1 is equal to m2. When L1 is perpendicular to L2, so theta must be equal to pi upon 2 or 3 pi upon 2. Okay, so when tangent tan theta pi upon 2, so this will be m1 minus m2 upon 1 plus m1 and m2. So this must be here 1 over 0 is equal to m1 minus m2, here 1 plus m1 and m2. So we can say that by cross multiplication 1 plus m1 m2 is equal to 0. So m1 into m2 is equal to minus 1. So the lines are perpendicular, then product of the slope is equal to minus 1. Okay, so now the other topic is the various forms of the line. Various forms of the line. Various forms of line. Okay, so number 1, parallel to y-axis. So when parallel to the y-axis, here this is the y-axis and here is the line. In right side, so we can say this will be x is equal to c. Or in here, this side then will be x is equal to minus c. But when it will be here in on the y-axis, so this will be x is equal to 0. Okay. So when number 2, parallel to the x-axis, so we can say the line parallel to x-axis, so the line is here. When line is upward, so this will be, we can say that y is equal to c. C units here. This is the c units above the x-axis, and when here the c units or minus c units below the x-axis, so this will be y is equal to minus c. And line is the parallel to the itself of the x-axis, so we can say y is equal to 0. Okay. Now slope intercept from point slope form. Here we have a point. This will be the point. So point is the x, y, and here the point P2, x2, y2, and here the point P1, x1 and y1. So when we draw the slope, so this line is a parallel. So the slope from P1 to P1 to P. So this will be y minus y1 upon x minus x1, and the slope P1 to P2 is equal to y2 minus y1 and x2 minus x1. So these lines are so the slope in on the same line, so the slopes are equal. We can say these points are the collinear points. When the points are collinear, then slope between them is equal. So we can say here this will be P1, slope of P1 P is equal slope of P and P2. So this will be y minus y1 upon x minus x1 is equal to y2 minus y1 and here x2 minus x1. We can write this as this line we can write here by cross multiplication y minus y1 here y2 minus y1 is equal to x minus x1 upon x2 minus x1. Okay, so this is the point slope form. Point slope form. So when line passes through origin, when the line passes from here origin, so this will be x2 x y2 is equal to 0 comma 0. Okay, so this will be, we can say y minus y1 upon minus y1 is equal to x minus x1 upon minus x1 minus we can cancel y upon y1 minus y1 upon y1 is equal to x upon x1 minus x1 upon x1. So y1 will be cancelled and y1 x1 will be cancelled. So y upon y1 is equal to x upon x1. Because here this will be minus 1, here minus 1. Minus 1 will be cancelled and minus 1. Okay. So this is the point and 2 point form, we can say. This is a 2 point form. 2 point form. Now for point slope form. Point and slope form. Point and slope form. Point slope form. Point slope form here. So this is the point. This point is the p x comma y, and this point is here p1. So this is the x1 and y1. So the slope is here, must be here. We can say it. M is equal to y minus y1 upon x minus x1 by cross multiplication. Y minus 1 is equal to m into x minus x1. Okay. So this is the point and slope form. When line passes through the origin, line passes through the origin. So this will be x1, y1 is equal to 0 comma 0. So we can say y is equal to mx. Okay. Again, we can say another forms for the equation. So this will be slope intercept form. Slope intercept form and 2 point form and perpendicular or normal form. Slope intercept form. Slope intercept form. So when we can say this is the line, this is the here line, and this is the y-axis and this is the x-axis. So here this is the intercept form and this here the theta. So here we can say this is the point x, y, and here this is the point A. This point is called B, and so we can say this is also theta here. This point is C, and this also we can say this is D. So tan theta here, this line, this is the x, so this is also x, this is also x, and this line is this is the y. So we can say that PD is equal to BD minus PB minus PB. So PD is equal to, this will be BD is equal to C, and this is the Y. Oh, sorry, not B, plus, okay, plus. So here we can say, when we can find this will be equal to, so PD is equal to BD plus PB. Okay, so we can say this is a C, this is a C, and here this also C, and this is the X. So when we can say this is a theta, so the line here, this is the Y. So we can say the complete line PD is equal to PB. So we can say that PB is equal to PD minus BD. Okay, so this will be PB is equal to C is equal to Y minus C. So and tan theta is equal to, here we can say that y minus c upon x. So this is the slope m. So this will be y minus c upon x. So this will be y minus c is equal to mx, and this is equal to mx plus c. This is the slope intercept form where c is equal to 0. So this will be y is equal to mx. So we can say that line passes through the origin. When m is equal to 0, it means slope is equal to 0. Then we can say y is equal to c. It means line parallel to the x-axis. When m is equal to 0 and c is equal to 0, then y is equal to 0. It means line parallel to the x-axis itself. Okay, and other is the two intercept form. Two intercepts form. Two intercept form. Now, how can define the two intercept form? Two intercept form, we can define what the two intercept form. Two intercept form is here. This is the Cartesian coordinate system. Cartesian coordinate system, and this is the line. So here this is the x-axis, and this is the y-axis. So here first intercept is here, and this is the a. So we can say this is a comma 0, and this is the point B, and here this is the 0 comma B. So the length of this side is a, and this side is the B. Okay. So now we can say here we can say, we can draw this a point here. So this point is B. So here x comma y, and this is the m. So this is a perpendicular from here. So this is the O. Okay. Here we can say OA is equal to OM plus m a. Okay, plus m a. So here this line is x and this complete line is the a. So OA is equal to x plus a. Got x plus a. So this is the no. We can say, we can find here OM. So OM is equal to OA minus MA. So OM is equal to A minus X. Okay. So now here this is line is a Y. This is a Y. So we can say here triangle BOA and triangle PMA are similar triangles. These are similar triangles. So we can say here B y upon B is equal to, so we can say this side, this complete side is and this side, the ratio of these sides is equal to complete this side and here short this side. So ratio of these sides also equal. So we can say that here MA upon OA. Okay. So now MA is the x. So this is the y upon b. So this MA is the x, and here MA. What mean MA? MA from find from here MA. We can say MA is equal to OA minus OM. Okay. So this will be A minus X upon A. Okay. Okay, now we can say A minus X upon A. So this will be Y upon B is equal to A upon A minus X upon A. A will be cancelled in A. Y upon B is equal to 1 minus X upon A. So this is the negative here. We can shift here. This will be positive. So X upon A plus Y upon B is equal to 1. So this is called two-intercept form. Okay. Now the last topic, last definition. Last definition is perpendicular or normal form. Perpendicular or normal form. Perpendicular or normal form. Perpendicular or normal form. So this form is here x cos alpha plus y sin alpha is equal to p. How to try this? So here this is the Cartesian coordinate system. So here this is the B and this is A and here this is the O. Right, this line is here. This is the perpendicular line. This is the N and we can draw here. This is the line. So this is also alpha and here also angle alpha. Okay. So this is the P from triangle ONA. Triangle ONA. So we can say cos alpha. Cos it means perpendicular, so edge side into hypotenuse. So this is the address side and this is the hypotenuse. So we can say P upon hypotenuse is here OA. Okay, OA. So we can say P is equal to OA into cos alpha. Okay, now this is the point P, x comma y. This is the m and this is the x and this is the y. So here tangent tan alpha is equal to perpendicular. It means the perpendicular m a upon here p m. M a is equal to p m. So we can say that here this will be O A is equal to O M plus M A. So we can say here M A is equal to O A minus O M. Okay, minus O M. So O A here. So we put here this will be here this will be, we can say that this will be P is equal to OA cos alpha. So when can we can say that tan theta here this will be OA in OA. So we can say that this will be P, not P, oh, okay, P M and MA. MA. Okay, so this is the x, this complete A and this is x. Okay, so O is here P, PM. PM is this P 10 alpha, PM is equal to MA. Okay, so we can say that PM is a bar, so 10 alpha is equal to PM. So we can say here P is equal to here, P is equal to here we can say O M plus Y M A, it means M A cos alpha. So this will be equal to P is equal to here x plus y into tan alpha into cos alpha. So P is equal to x cos alpha plus y into tan alpha into cos alpha. So P is equal to here x cos alpha plus y, tan is here sin alpha upon cos alpha into cos alpha. Cos alpha will be cancelled. So P is equal to x cos alpha plus y sin alpha, and we can write this as x cos alpha plus y sin alpha is equal to P. Okay. So this is all about the chapter number 2, the straight line. All formulas we have to drive here. If you have any problem regard this, you will text me or you contact me. I will give you complete explanation. Okay. Thank you for watching.